Hey everybody, welcome back to the channel. We're going to get back into the lasers for today. So, in this very first lesson at Laser University, Level 101, we're going to talk about focus. But before we do that, let me take these off. I mean, eye protection is always the most important thing, but we're not going to be turning on any lasers today. So I can get rid of that. I got to focus my own eyes. So, we're going to talk about focus today. So, there are two things that determine how you focus your laser. Now it kind of depends on which type of, well actually it doesn't depend. Whether you're using, what I have here is the laser assembly for a diode laser. Right down here is the lens for the diode. The diodes are actually inside this piece here. And since I can't bring my whole CO2 laser into my house, and my garage where that lives is about 100 something degrees right now, I didn't want to drag you out there. I just brought in the bottom piece of the laser head assembly for the CO2 laser, and right here is the lens for that. So we're going to talk about those two pieces. Now, as the light travels through the assembly, and again, this is a CO2 laser, so we have our CO2 tube here. It's bouncing off our first, second, and third mirrors, and then it comes down, and this piece right down here is the focusing lens. So these two would show you the lens itself, and this is just getting more technical than we're going to go into today, but basically your laser beam has a width, and it is going to focus that down into a cone. And that's going to give you your, where all of that energy is concentrated. So, both of these have a lens inside. As I showed you here in this diode laser, there is a lens inside this brass tube. And in the CO2 laser, that you can probably, as I move this around, you can probably see the top of the lens there. So every lens has what's known as a focal distance. Now, that distance, the distance between the lens and where your laser energy is focused at the smallest point is called the focal distance. Now that is something that you have control over. On a diode laser, this distance is typically a lot shorter than what you would see on a CO2 laser. So you typically control that focus by raising or lowering the head, the complete assembly, to whatever it would be you're engraving on. On a CO2 laser, since it's on a gantry and that's fixed, we typically change that distance by raising and lowering whatever it is that we want to engrave or cut. So you probably have a honeycomb bed or knife blades or something like that. This stays at a fixed position, but we raise and lower the bed to control that focal distance. On a CO2 laser, you're typically going to have, it's going to come with kind of a jack-of-all-trade lens, right? So this lens right here is a 2-inch lens. This is a good median between engraving performance and cutting performance. So I created this little illustration basically to show you. Now, from this point, which would be the bottom of the lens, you can see the top part here is slightly curved to indicate the lens. So here we have the lens. Then from the bottom of the lens to this point is 2 inches. So this would be a representation of how this would be set up. So I've got this roughly where the lens is, and so 2 inches below that is where this comes into focus. Now, what you can see here is this is illustrating that the beam is getting narrower, and at one point the beam converges to its smallest point, and then it actually starts getting wider again. So you would want to be 2 inches from the bottom of this. Now, we typically can't measure, because again the lens is inside here, so we can't measure this distance. So we typically are going to measure the distance from a known position. So in this case, this is the air assist cone. So the bottom of this to whatever we were engraving or cutting, we have a fixed distance. Now, in my case, this is 18 millimeters from here to the surface is going to be what's in focus. On a diode laser, again, we're dealing with typically much shorter distances, shorter focal length on the lens. The way that this gets focused is with this card. This card is 2 millimeters thick. So when I'm using this device, or when I'm using the diode laser, I basically put this card and then I lower the head down to where I just have this 2 millimeter distance here. And that's how I know that this is in focus. Now, how do I know that I'm in focus? Well, we're going to get into that in a later video, but with a diode, it's kind of difficult to do. You can't really do, we're going to talk about the ramp test, which is typically done on a CO2 laser. Now on a unit like this is again a diode laser. It operates at around 450 nanometers, which is actually visible to the human eye. If you've used one of these, you know that the laser is blue. If this is way up here and out of focus, you're going to see a big blue dot. As you get it lower and lower and lower, and once you're in focus, you're going to see that that dot shrinks down to, you know, the size of a pin. It's very tiny, so you can actually see when this is in focus or not. Now, in a CO2 laser, it's infrared. You can't actually see the beam, you can only see the results. So what we do is something called a ramp test. Now, I'm going to make a separate video on this. I'm just going to cover this very briefly. But basically what we're doing is we are taking since this is always going to operate at the same distance, right, because it's on that gantry, and unless you, well, we won't even go into moving your bed during a cut. One way to figure out exactly where the beam is in focus is to do this ramp test, and all that is moving the laser head while it's burning on something that has a variable distance, i.e. a ramp. So if we had it here, I've got, you know, if it's touching here, I've got pretty much next to no distance between the bottom of this and here. And then as I move along, the distance is increasing, increasing, increasing. And what I would expect to see from that is basically something that looks like this. When it's out of focus, I'm going to have kind of a big dot, and that line is going to get thinner and thinner. I should probably color this in so that it doesn't look like, you know, you wouldn't actually see two lines. You would see at some point here, that line is going to get thin, and then at the thinnest, and then it's going to start to get thicker again. And that would be wherever that lined up, wherever that line was thinnest, that's where it's going to be. Now, again, you're verifying. So in my case, I know that this is about 18 millimeters, and that's where I'd expect that to be. But that's a good way of ensuring that you're not just going off what the manufacturer told you, which hopefully should be right, or what you read on the internet. You're actually doing a ramp test, and then you know that things are in focus. Now, why is focus important, right? Focus is important because you're trying to maximize all of that optical energy into the smallest area possible so that you can have the best effect on whatever it is that you're trying to either engrave or cut. So as we've already talked about, we want to be operating right in this point right here, where all of our energy is concentrated into this smallest area. So if we have a set focal distance lens, in this case that's a 2-inch lens, I know 2 inches from the bottom of that, that's where I'm going to have my most of my optical energy located, then that's going to give me the optimal results. Now, is every lens best for the job? Like I said, this lens is a good um, you know, median of engraving and cutting. Let's talk a little bit about why that makes a difference. If you've been around in, you know, your laser forums for a while, you probably hear about different size lenses or different focal length lenses. So this representation here is showing a 4-inch lens. So this would have a focal distance of 4 inches. Now, what I've done here is I've made another one similar to this, whereas this one from the bottom of this point here to here is 2 inches. This would be a 4-inch focal length lens. So bottom from this line, the bottom of the lens, to this point is 4 inches. Why would you want to increase that distance? Well, the reason that you do that is to give you this increased workable area here, or depth of focus. So a lens like this, if you look at, and these are just rough estimations, there's no science between this or behind what I've drawn here. There is science in, you know, the real world, but these are just for illustrative purposes only. You can see that the depth of focus here on the 2-inch lens is less than what you see here on the 4-inch lens. So the 4-inch lens with this greater distance is going to be better for cutting through a thicker material because there's a greater workable area here. It is staying in focus for a longer period of time, whereas this one converges and then diverges fairly quickly. The 4-inch lens converges and diverges over a longer period of time, so you can cut through thicker things. Now the offset to that is that when you a 4-inch lens is actually going to have a bigger spot size, so it's not going to be as good for things like engraving, because it's kind of the difference between using, you know, if you were trying to do fine detailed drawings and you've got a very thick marker that is always making, you know, fat dots, you could equate this to say like your 4-inch lens versus your 2-inch lens with a much finer dot size. Let's see if I can, probably not, this will be the worst 2 ever, but you know, the 2-inch lens has a much finer spot, and then they also make even, you can get like a 1.5-inch lens that would have an even smaller dot size, which would be better for engraving. Now, that being said, don't run out and buy a 4-inch lens just because you want to do deeper cutting. There is a, they even talk about this, you know, my manufacturer, Ohmtech, if you go to places like American Photonics, they'll talk about the lens sizes, etc. There is a little bit of a drawback, and I'm gonna read this from my notes here, but right off of the manufacturer's website. This came from the Ohmtech size. It says the focal lens can affect the machine's power by changing the laser beam's dot size diameter. A 60-watt machine can only produce 60 watts of maximum power no matter which focus lens is used, but larger lenses will typically increase the beam dot size, which lowers the energy density of the laser beam. i.e., if I'm putting all 60 watts and this is as small as I can get it, there's only so much that I can do. If I can pack all 60 watts into a dot size of, you know, that's much smaller, it's going to have a bigger effect on whatever it is that I'm working with. And I'll continue on. It says that means that using a typical 4-inch focal length lens with a 50-watt laser tube will actually decrease your cutting ability because the larger beam is wider and less dense. Keep this in mind when choosing your focal lens for laser cutting. While a 3 or 4-inch lens is great for cutting on a high power laser, it is not ideal for a mid-range laser. So hopefully that explains focus a little bit. In future videos, I'm going to discuss things, the next lesson actually that we're going to talk about is speed and power. There's a relationship between speed and power, and it's really important that you understand that. Once you can mentally process that and understand that relationship, it'll make working your laser and achieving the results that you want a lot easier. So I hope you've enjoyed what I'm doing here. You know, if you enjoyed this video, if you found these demonstrations useful, please hit that like button. Go ahead and subscribe to the channel. It just helps me to continue to make future videos, and I know that I'm actually making a positive impact in the community. So, you know, I normally like to say, let's keep burning together, but at least for the Laser University, we'll just say, let's keep learning and burning together. Take care.